objective of this course is to demonstrate computer programming fundamentals, starting with the computer programming language procedure-oriented paradigm, and then migrating to today's dominant computer programming language object-oriented paradigm, while demonstrating the core computer programming fundamentals that have withstood the migration and which apply to both computer programming language paradigms. The C computer programming language will be used to demonstrate these core computer programming fundamentals for the computer programming language procedure-oriented paradigm, while the Java computer programming language will be used to demonstrate these same core computer programming fundamentals for the computer programming language object-oriented paradigm. Interestingly enough, these core computer programming fundamentals have been preserved during the migration from the computer programming language procedure-oriented paradigm to the computer programming language object-oriented paradigm. As such, this course concentrates on mastering the core computer programming fundamentals as opposed to mastering a specific computer programming language, a common mistake which most computer programming courses make, because once mastering of the core programming fundamentals is achieved, mastering a number of specific computer programming languages is within easy reach. The democratization of education is a relatively new concept for the dissemination of information. Moreover, the democratization in education, aided by dramatic advances in information technology, have forced a major change in traditional academia, a change I might add for the better. No longer are students or facilitators restricted or constrained in the educational collaboration process. The educational collaboration process of delivering and receiving information to disseminate knowledge. Students can now receive information anytime, anywhere, and in any form on demand. Facilitators can now reach an expanded, diverse, and mobile audience. As such, traditional academia, as we know it, is changing radically for the betterment of students and facilitators alike. This is what I call the democratization of education. The course is based on real-world experience. True knowledge requires application of learning objectives to produce real-world outcomes. It is one thing to have taught computer programming. It is another to have developed computer programming application solutions for the real world. The ideal facilitator has done both. The primary approach of the course is to focus on the core computer programming fundamentals. Those core computer programming fundamentals central to all computer programming languages. By emphasizing the core computer programming fundamentals, while at the same time ignoring limited value features of a specific computer programming language, ensures that the core computer programming fundamentals are mastered. Rigor for rigor's sake is a mistaken objective for acquiring knowledge. This is the old quality versus quantity argument. Traditional academia may favor quantity and working hard, but my experience for being successful in the real world favors quality over quantity and working smart over working hard. Availability of information is a critical component of the course. The course is purposely presented in a form that will allow you to review lectures on your schedule. The course provides you with hands-on as well as how-to capability. Both are essential for you to successfully master the core computer programming fundamentals of the course. As such, the course shows you how to establish a development environment to code and test your computer programs. Additionally, the course provides lectures on how to download the free tools. Tools you will need to support the C programming language and Java programming language development. All materials supporting the course are available at no additional cost. There is no text to buy. There is no development software to buy. The Miracle C workbench is used to support the C computer programming language. The J2SC Java development kit is used to support the Java computer programming language. A text editor such as Notepad is used to develop source code for both computer programming languages. The command processor is used to execute your executable code. All these tools can either be downloaded for no additional cost or are already resident on your computer. Everyone refers to me as Dick. That's me at the right-hand bottom corner of the slide. After obtaining an MBA in operations research, I began my professional career with a Big 8 public accounting firm. I began working immediately in the consulting division. I don't know why I avoided the audit division. I guess I was just in the right place at the right time. My first project was the design, development, and implementation of a traffic unit system, a system that tracked natural gas movement through a pipeline from the Gulf of Mexico to storage facilities in the upper Midwest. I programmed the system in the COBOL computer programming language with a little help from the assembler computer programming language. My first project became an unexpected pleasant surprise, as computer programming was not on my future radar screen, for I was introduced to computer programming in college using the Fortran computer programming language to solve our operations research mathematical models. I hated the process of punching cards, compiling, debugging, and waiting for results of my very first computer programming effort. I vowed I would never wanted to perform any projects that involved computer programming. Only operations research projects were on my future radar screen. Well, as destiny had it, goodbye operations research, and hello computer programming. I then progressed up the information technology career ladder from programmer, systems analyst, project leader, and finally to consulting practice leader. The next step in my professional career involved creating, developing, and managing information technology consulting practices for large information technology consulting firms. Finally, I had enough experience to form my own information technology consulting firm. I just wanted to be my own boss where I could choose my own consulting engagements. Consulting engagements that were both challenging, interesting, while providing positive outcomes. Furthermore, I wanted to be involved in consulting engagements that utilize the application of emerging information technologies. Emerging information technologies to improve business processes, provide a positive return on investment, and result in sustained positive value proposition outcomes. This led to an enterprise application integration practice, a practice where I became a pioneer in developing custom programming interfaces. Custom programming interfaces covering a diverse set of computer programming application solutions. Those computer programming application solutions based on a myriad of specific computer programming languages. This required that I understand the core computer programming fundamentals. Those core computer programming fundamentals that pervade all computer programming languages. While managing the systems practice for a Big 8 public accounting firm, I received a cold call from a college department chair. The college department chair was looking for full-time faculty to join his new Department of Computer Information Systems. The purpose of the Computer Information Systems Department was to complement the college's business school. While a full-time faculty position was out of the question, I agreed to become an adjunct professor. I started with a Saturday morning class directed at MBA students for the purpose of introducing computer programming fundamentals. From that point on, I complemented my professional career with an academic career as an adjunct professor. In those days, I was known as the night guy with industry experience. After serving as an adjunct professor for a number of years, I set a goal to achieve my doctorate in computer science. I enrolled in a Doctor of Philosophy program for computer science and retired to write my dissertation. My dissertation was entitled Component Object Architecture, Model Development Lifecycle. The dissertation argued the virtues of physical models over logical models as they transition through the traditional systems development life cycle. Well, retirement did not last very long, as I took on a full-time position as a college campus chair for a College of Information Systems and Technology. This is like a college dean position, where you are responsible for recruiting, mentoring, and managing faculty, as well as ensuring academic standards are met through curriculum development. After 7 years as a college dean and some 30 years as an adjunct professor for a number of universities in both on-campus and distance learning environments, I entered a third career by establishing the Institute of Information Technology. The Institute's mission is to provide digitized lectures based on my 30 years of experience as an adjunct professor and 40 years plus as an IT consultant. Digitized lectures attuned to what I and others now call the democratization of education. This course is my first effort in that regard. Hope you like it. Computer Programming Fundamentals course consists of 23 lectures, comprising over 8 hours of lecture time, confined to over 200 PowerPoint slides with voiceover narratives. The course concentrates on core computer programming fundamentals, common to all computer programming languages. Thus, the focus is the core computer programming fundamentals, rather than a specific computer programming language. Because demonstration computer program models are required to master these core computer programming fundamentals, the C and Java computer programming languages have been chosen to support the demonstration computer program models, where the C computer programming language represents the computer programming language procedure-oriented paradigm, whereas the Java computer programming language represents today's dominant computer programming language object-oriented paradigm. Another reason for choosing the C and Java computer programming languages is that for both computer programming languages, computer programming development tools can be downloaded free from the internet. As such, computer program development environments can be established at no additional cost. In this regard, lectures on establishing the computer programming development environments for both the C and Java computer programming languages are provided. Note that the course begins with an introduction lecture describing the computer programming development process. The computer programming development process independent of any specific computer programming language. Next, a history of computer programming languages is provided from before 1940 to today. Next, the core computer programming fundamentals are presented in the first part of the course, C lectures 3 through 9, using the C computer programming language. In the second part of the course, namely lectures 10 through 15, the very same core computer programming fundamentals are presented using the Java computer programming language, emphasizing that what is most important is the core computer programming fundamentals rather than a specific computer programming language, especially when these core computer programming fundamentals pervade all computer programming languages, even when these core computer programming fundamentals have successfully withstood the test of time by successfully migrating from the computer programming language procedure-oriented paradigm to today's dominant computer programming language object-oriented paradigm. Lecture 1, Introduction, introduces the core computer programming fundamentals by presenting what I believe everyone should know before embarking on any computer programming course. In this regard, 6 key fundamental computer programming development issues are discussed: the hardware operating system application software hierarchy, the general purpose computer, the common computer program architecture, the procedural-oriented, object-oriented programming transition, the preprocessor compilation build execute process, the object-oriented environment. Lecture 2, Computer Programming Languages, introduces a series of lectures on the history of computer programming languages. The history of computer programming languages from the beginning in 1801 to the current day. The following series of lectures will present computer programming languages introduced for the time periods, namely lectures L2A, Computer Programming Languages before 1940, L2B, Computer Programming Languages the 1940s, L2C, Computer Programming Languages the 1950s, L2D, Computer Programming Languages the 1960s, L2E, Computer Programming Languages the 1970s, L2F, Computer Programming Languages the 1980s, L2G, Computer Programming Languages the 1990s, L2H, Computer Programming Languages the 2000s. I purposely included the Lecture 2 series of lectures to trace the evolution of computer programming languages because it broadens the understanding of the core computer programming fundamentals, specifically how and when the core computer programming fundamentals originated, evolved, and advanced the technology of computer programming. Lecture 2A, Computer Programming Languages before 1940, focuses on the evolution of computer programming languages before the year 1940. Two key computer programming language evolution events took place prior to 1940, namely the Jacquard loom and Bernoulli numbers. Lecture 2B, Computer Programming Languages, the 1940s, focuses on the evolution of computer programming languages for the 1940s. One key computer programming language evolution event took place in the 1940s. The evolution event of the development of the first high-level computer programming language. The first high-level computer programming language's generic name was Plan Calculus, but spelled as Plankalkul with an umlaut over the U by its German developer. Lecture 2C, Computer Programming Languages, the 1950s, ushered in the era of general-purpose computer programming languages. Specifically in the 1950s, general-purpose computer programming languages of assembly language, autocode, Fortran, Lisp, ALGOL, COBOL, RPG, many of which are still around today, especially for general-purpose mainframe computers, for which they were originally intended. Lecture 2D, Computer Programming Languages, the 1960s. Computer programming languages that set the stage for today's dominant computer programming language paradigm, namely the computer programming language object-oriented paradigm. Specifically in the 1960s, computer programming languages of Simula, Snowball, APL, BASIC, PL1, and B became the forerunners of today's computer programming languages, forerunners that support the computer programming language object-oriented paradigm. Lecture 2E, Computer Programming Languages, the 1970s. Computer programming languages for the 1970s introduced the computer programming language best practices, namely structured programming principles that led to the creation of reliable computer program code. Reliable computer program code independent of a specific computer programming language. Specifically in the 1970s, computer programming languages of Pascal, Forth, C, Smalltalk, Prolog, and SQL began an era of computer programming best practices that continues today. Continues in today's computer programming languages to provide reliable, maintainable, reusable, and secure computer program code. Lecture 2F, Computer Programming Languages, the 1980s. Computer programming languages for the 1980s introduced the computer programming languages geared for the mini-computer. The mini-computer then led to the personal computer. The personal computer's demand to be connected led to local area networking technology. Local area networking fostered the change to client-server architecture from the traditional central server architecture. Computer programming languages that emerged during the 1980s include C++, Ada, Eiffel, Perl, FL. Computer programming languages that provided computer programming application solutions. Computer programming application solutions that operated on the network. The network then became the computer supported by client-server architecture. Lecture 2G, Computer Programming Languages, the 1990s. Computer programming languages for the 1990s introduced the computer programming languages geared for the World Wide Web. This era of computer programming languages was achievable by maturation of the Internet, where technologies of local area networking, client-server architecture, and the personal computer converged with Internet technologies and the browser-based client to make the World Wide Web a reality. Computer programming languages that emerged during the 1990s include Python, Visual Basic, HTML, Ruby, Java, JavaScript, PHP, and XML. Computer programming languages that provided computer programming application solutions. Computer programming application solutions that operated on the World Wide Web. The World Wide Web then became the computer of choice, a computer directed by the user's universal client, the universal client being a browser-based electronic device, everything from personal computers to smartphones. Lecture 2H, Computer Programming Languages, the 2000s. Computer programming languages for the 2000s introduced the era of visual rapid application development. Visual rapid application development methodologies that reuse proven computer programming components, where assembly of a computer programming application solution trumps the coding from scratch of that computer programming application solution. Computer programming languages that emerged during the 2000s include C#, Visual Basic.NET, F#, Groovy, Clojure, Go, and Dart. Computer programming languages that provided computer programming application solutions. Computer programming application solutions that are based on generated computer programming code. Generated computer programming code based on the assembly of proven, reusable computer programming code component objects. Lecture 3, Computer Programming Development Environment. Establishing a viable computer programming development environment is essential in any computer programming course for demonstrating the core computer programming fundamentals via the development of computer programming models that demonstrate the core computer programming fundamentals. As such, Lecture 3 presents two essential features for establishing a viable computer programming development environment, namely the establishment of multiple concurrent sessions combined with a working directory. Lecture 4, Computer Programming Development Tools. Lecture 4 addresses the computer programming development tools required by the computer program development process. The computer program development process of source code development, compilation of source code, build of compiled object code, and execution of the combined executable. Where Notepad is used for source code development, where the Miracle C workbench is used for compilation of source code and the build of compiled object code, where the command processor is used for the execution of the combined executable. Here the traditional Hello World computer program model is taken through the computer program development process using the three tools of Notepad, the Miracle C workbench, and the command processor. Lecture 5, L5.C, Hello World. Lecture 5 traces the source, compile, and build and execute computer program development process for your first computer program model, namely the computer program model L5.C, the Hello World computer program model developed using the C computer programming language. Lecture 6, C Basics. Lecture 6 presents a number of C computer programming language computer program models. Computer program models that demonstrate the core computer programming fundamentals. Core computer programming fundamentals presented in the context of the C computer programming language. The computer programming language based on the computer programming language procedure-oriented paradigm. The computer programming language that established the core computer programming fundamentals. Core computer programming fundamentals are basics that have been preserved over time. Core computer programming fundamentals prevalent in today's dominant computer programming languages. Today's dominant computer programming language is based on the computer programming language object-oriented paradigm. The core computer programming fundamentals are demonstrated via computer program models. Computer program models that address the following basic principles of any computer programming language, namely computer organization, data types, operators, expressions, statements, and functions. Lecture 7, Structured Programming in C. Lecture 7 addresses structured programming using the C computer programming language. The C computer programming language was the first computer programming language to address structured programming. Structured programming introduced computer programming best practices. Computer programming best practices to provide more reliable, modular, and maintainable computer program code. To demonstrate structured programming best practices, 6 computer program models are presented and discussed. Control structure sequence, control structure for loop, control structure do-while loop, control structure while loop, control structure if-else, control structure switch. Lecture 8, Modular Computer Programming using C. Lecture 8 addresses the issue of modular programming. Here, proven computer program models L7A.C through L7F.C are incorporated into one single computer program model, namely one single computer program model called L8.C, where computer program model L8.C incorporates each computer program model L7A.C through L7F.C as a function, each as a separate function within computer program model L8.C, where each separate function is called from within computer program model L8.C's mainline. Lecture 8 includes 5 slides that demonstrate computer program model L8.C's modularity, namely modularity L8.C, L7A.C through L7F.C, function declarations, function calls, function executions, and mainline control specifically for function L7A. Lecture 9, Arrays in C. Lecture 9 addresses the processing of arrays in the C computer programming language. Since the string data type was not available for the C computer programming language, character arrays were used as a workaround for this deficiency in the C computer programming language. As such, Lecture 9 devotes 6 slides and 4 computer program models for the demonstration of arrays, namely no strings, arrays, numerical array, L9A.C, character array, L9B.C, two-dimensional array L9C.C, two-dimensional array L9D.C. Lecture 10, Establishing the Java Computer Programming Environment. Lecture 10 makes the transition from the computer programming language procedure-oriented paradigm to the computer programming language object-oriented paradigm. By making the transition from the C computer programming language to the Java computer programming language. In order to accomplish this transition, we must first establish the Java computer programming environment. Establishing the Java computer programming environment is presented by 15 slides, namely Java, establish the Java virtual machine, or JVM, download the Java Development Kit, select Java SE, download latest JDK, JDK 7, download JDK Security Warning, JDK Setup, JDK 7, JDK Directory Location, JDK 7, JDK Root Proximity, JDK 7, JDK C:\JDK 7, Java Runtime Environment, Java 7, JRE Directory Proximity, Java 7, JRE Java 7, JDK and JRE installed, establishing path environment variables, the compile runtime development cycle. Lecture L11, L11.Java, Hello World. Lecture 11 demonstrates the Hello World computer program model under the Java computer programming language in the same manner as Lecture 5, which demonstrated the Hello World computer program model under the C computer programming language. This not only shows the computer language syntactical similarities between the two computer programming languages, but more importantly demonstrates the seamless migration from the computer programming language procedure-oriented paradigm to today's dominant computer programming language object-oriented paradigm. Lecture 11 includes 5 slides that demonstrate the Java Hello World computer program model, L11.Java, namely L11.Java Hello World My First Program, JDK 7.bat, source code, compile and class load, execution results. Lecture 12, Java Basics. Lecture 12 presents a number of Java computer programming language computer program models. Computer program models that demonstrate the core computer programming fundamentals. Core computer programming fundamentals presented in the context of the Java computer programming language. The computer programming language based on the computer programming language object-oriented paradigm. Much like Lecture 6, C Basics, that demonstrated the same core computer programming fundamentals using the C computer programming language, the computer programming language that initially established the core computer programming fundamentals under the computer programming language procedure-oriented paradigm. Core computer programming fundamentals or basics that have been preserved over time. Core computer programming fundamentals that have migrated successfully intact to today's dominant computer programming languages. Today's dominant computer programming language is based on the computer programming language object-oriented paradigm, namely the Java computer programming language, today's dominant computer programming language. Core computer programming fundamentals are demonstrated via computer program models. Computer program models that address the following basic principles of any computer programming language, namely computer organization, data types, operators, expressions, statements, and methods. Lecture 13, Structured Programming in Java. Lecture 13 addresses structured programming using the Java computer programming language. Although the C computer programming language was the first computer programming language to address structured programming, these same structured programming best practices have been carried over to the Java computer programming language. Computer programming best practices to provide more reliable, modular, and maintainable computer program code. To demonstrate structured programming best practices, 6 computer program models are presented and discussed, namely sequence, for loop, do-while loop, while loop, if-else, and the switch. Lecture 14, Class Creation and Execution in Java. Lecture 14 addresses class creation and execution using the Java computer programming language. Where class creation and execution is a major feature of computer programming languages based on the computer programming language object-oriented paradigm, where the Java computer programming language is used to demonstrate user class creation, reuse, and execution. To demonstrate the object-oriented features of the Java computer programming language, Lecture 14 creates class instances representing the 6 control structures supporting structured programming best practices. The same control structures that were discussed in Lecture 8 under the C computer programming language, where modularity was discussed in the context of the C computer programming language. Here in Lecture 14, modularity is discussed under the context of the Java computer programming language, namely putting it all together by creating instances of classes. Class creation, sequence L14A, sequence L14A.java, repetition L14B, for L14B.java, repetition L14C, do-while L14C.java, repetition L14D, while L14D.java, decision L14E, if L14E.java, decision L14F, switch L14F.java, class execution, source code, class creation, results. Lecture 15, Java Applets. Lecture 15 discusses the significance of Java Applets for popularizing the Java computer programming language by providing user interactivity to traditional web pages, providing user interactivity under a secure computer programming environment, while reusing the extensive and robust Java class libraries. Java class libraries that provide classes to extend HTML computer program code. As such, Lecture 15 demonstrates how Java applets extend traditional HTML computer program code, namely enhancing web pages, applets plus HTML, label class L15A.java plus L15A.html, label class results, JLabel class L15B.java plus L15B.html, JLabel class results, JLabel class with fonts L15C.java plus L15C.html, JLabel class with fonts results.